Okay, we're now ready to learn some more important things about graphing lines. So in 4.7, the I can statement is I can graph linear equations. So we've got a new word here, linear. Linear equations using tables. We're going to learn lots of different ways to graph lines, but the first way we're going to learn is tables. So in the warm-up here, again, review of what we've talked about so far in this unit. So M represents slope. You can kind of think mountain slope there. If we've got a graph, then it's the rise over the run. And if we've got points, then the formula is y2 minus y1 over x2 minus x1. We've got a little statement here to finish off. It's about slope, and you'll notice that there are more blanks here than there have been in the past. So slope is a fraction that describes how steep a line is and in which blank it blanks, so in which direction it slants. Alright, so there's the full statement there. It's a really good idea to be able to describe what slope is. So again, slope is a fraction that describes how steep the line is and in which direction it slants. And then on C, we've got some examples of positive slopes, negative slopes, zero slope, and no slope. And remember, another way that you can describe no slope is you can say the word undefined. And when we say that, what we mean is there's no number that represents how steep that is. Okay, so let's take a look at this one right here. This happens to be a vertical line, so remember, if you get dropped off here to ski, there's nothing for you to land on. That's going to be a cliff. So there is no slope on that, or you could say undefined. This one goes up from left to right, so this is a positive slope. This one is perfectly flat, so the slope on this one is 0. And then this one goes down from left to right, so that one has a negative slope. Okay, let's take a look at D here. It says x equals 7 is the solution to this equation because x equals 7. So if you were to plug that in right there, we get 2 times 7, that's 14, and 14 minus 4 does equal 10. It makes the equation true. Okay, and then the last one in the warm-up, it says, what is the root word of the word linear? Well, remember, the root word is just the word that this word comes from. So linear is kind of a weird word, but there's the root word right there. It's line. Okay? So, all right, now that we know what the slope of a line is, we need to know how to graph the line if we are given an equation. So we're getting back to a little bit more of an algebra base for this. So an equation whose graph is a line, look at that word right there, is called a linear equation. That's why that's in the I can statement for today. So we're going to be talking about graphing linear equations. And graphing these can be a little bit tedious, but we're going to get these right as long as we are very careful. Alright, so make sure you're careful as you're going through these. I don't think any of the calculations we're going to do are very difficult, but you do have to be a little bit careful. Now remember, lines are the simplest type of graph that we're going to learn, and we're going to get several techniques for graphing linear equations like I said earlier. Now what we're going to start out with is we're going to start out with a table. So go ahead and write the word table right here. Now it's important to remember that even though lines are fairly simple, you can graph nearly any equation using an XY table. So we'll write the word table here again. So here's the technique that we're going to use. There are 3 basic steps to graphing a linear equation using a table. The first thing is we're going to choose, or sometimes we're given the x's, and then we're going to find the y's that go along with them from the equation. Then we're going to plot those xy pairs on the set of axes, on the coordinate plane, and then we're going to connect the points to graph the line. And then please make sure when we're graphing a linear equation, or really any other equation, we want to extend the graph or extend the line in both directions in this case. So we're just graphing a line. We know that every single one of these is a linear equation, so it's going to make a line. So we want to make sure that the graph looks good when we're done. We want to make that line extend past or to the edge of every single one of the graphs. So here's the first equation that we're going to do. So we're going to graph y equals 2x minus 4. Y equals 2x minus 4. Here's the xy table that we were talking about. You'll notice some of those x's are already filled in. So remember, we've got to choose, or we're given the x's. We've been given two x's. We get to make a choice on these x's right here. And then we're going to find the y's that go along with them. Now, in the box off to the side here, it's got a little hint for making sure we do this right. It's usually a good idea to pick a few negatives, a few positive, and then always pick 0. Okay? So you'll notice that I've got a -3, I've got a +5, and then we've got a 0. And let's put that right there. Okay, so we want to make sure that there's going to be a 0 there. So I'm going to put a 0 right in the middle. Let's pick another negative number. Let's say we pick -1. And let's pick another positive number. Let's say we pick +2. Okay? So we've got our x's picked. Now here's how we're going to find the y's. So we're going to take this x, we're going to plug it in for that x right there, and then we're going to see what the y would have to equal in order to make that equation true. So this would be 2 times -3 minus 4. So again, the reason we're getting that is because the equation is y equals 2x minus 4. So the rule says, or this equation says, that if we want to find out what y is equal to 2 times whatever x is minus 4. So this is going to be 2 times -3, that's -6, minus 4, so we end up with -10. And here is an xy pair that we're going to graph. So we're just going to run through that down this entire table, and we're going to figure out what each one of them need to be. So this is going to be 2 times -1 minus 4. That's -2 minus 4, so that's going to be -6. This is going to be 2 times 0 minus 4, so that's 0 minus 4, so that's -4. And you'll notice these are pretty simple calculations. We're just using our integer operations to figure these out. This one's going to be 2 times 2 minus 4. 2 times 2 is 4 minus 4. This one happens to be 0. And then we get 2 times 5. We're just following that same pattern on every single one of these. So this is going to be 10 minus 4. So this is going to be a 6. And again, just as a reminder, I'm going to go through here and put parentheses around every one of these. Put a comma in between just to remind us that these are xy pairs. Okay? Now we're going to take each one of these, and I kind of like going in order, and we're going to graph each one. So this one is -3, -10. So we're going to go back to 1, 2, 3 on the x direction, and -10. And notice how this is scaled so we can count pretty quickly. -2, -4, -6, and so forth. So we're right here. So that first point is graphed. The next one is -1, -6. So we're going to go back 1, and then we're going to go down 6. So that would put us right here. Now, once we get 2 points on here, we should have a pretty good idea of what the line looks like. Okay, so it should look something like this. Now, if it doesn't line up, if we're graphing some of these other points and it doesn't line up, we've done something wrong. We've either found one of these points incorrectly, we've done our calculations wrong, or we've graphed something wrong. So we know that every one of these is going to be a line. So if they don't line up, we know we've done something wrong. So 0, -4. So that means we don't go right or left in the x direction, and we go down 4. So notice that this kind of lines up here, so it looks like we're in good shape. The next point we're going to graph is 2, 0. So that means 2 in the x direction, 0 in the y direction, so we don't go up or down at all. And again, we're still lining up. That's awesome. And then we've got 5, 6. So over 5, and then up 6. 2, 4, and 6. So we're right there. So that lines up really well. Looks pretty good. So I'm going to start right here, and I'm going to connect those dots. And then we're going to put an arrow on each end. And the reason we put an arrow on each end here, a lot of people have a tendency just to stop at their first point and their last point, is because we just happen to pick these points. We could have picked other points. We could have picked -10, we could have picked +8 or something like that. These are just a sampling of points that work in this equation. So we want to graph all of the points that would work in that equation. So we want to extend the line in both directions. Remember, a line goes forever in both directions. We're not graphing line segments, we're graphing lines. So make sure you put those arrows on the end here. Okay, so an arrow here and an arrow right there. Okay? Alright, so let's take a look here. A couple things to remember when we're graphing a linear equation using a table, or any linear equation for that matter. The graph is a picture. So go ahead and write the word picture right here. It is a picture of all the points that work in the equation. So you'll notice that we only graphed 1, 2, 3, 4, 5 points, and yet we made this entire line. If we zoomed in, we're saying that this point works, and this point works, and this point works. Every single one of those points and all of these in between, those would be on the line. And then there's something that a lot of people forget. It doesn't matter, whether you're in a really high math class or a low math class or something like that. If we've got a graph, that gives us a ton of information. It really is a picture of all the points that work in the equation. So the first thing is, if a point works in the equation, then it's on the graph. So we're going to put graph right here. Now this is true of linear equations and any other type of equation. So if it worked in the equation, so if these points make that equation true, then it's going to be on the graph of that equation. But the opposite is also true. If a point is on the graph, then it works in the equation. So that kind of goes both ways. So if we were to pick this point right here, let's take that one, and I'm going to do this one in blue. So this point right here is 4, 4. Okay, we went over 4 and up 4. Well, watch what happens. So if I put in a 4, 2 times 4 minus 4, that would be 8 minus 4, and guess what answer I get? We get 4. So even though we didn't find that point to begin with, because it was on the graph of that line, it definitely works in the equation. So please don't forget those. Those are really important to keep in mind. The graph is a picture of all the points that work in the equation, and if a point works in the equation, then it's on the graph, and if a point is on the graph, then it works in the equation. Okay, let's flip over to the other side and let's do another one. So the equation this time is y equals negative 3x. So y is equal to negative 3x, and you'll notice this is totally blank, so we can pick any points we want. So we want to keep in mind this idea right here. It's usually a good idea to pick a few negatives, pick a few positives, and then pick 0 for sure. So I'm going to put 0 right in the middle here. Now you could pick any negatives that you want or any positives that you want. You probably wouldn't want to go bigger than 10 or less than negative 10. So I'm going to pick this. I'm going to say we're going to pick negative 4. And let's do the point, say negative 2. And then on this side, let's pick a positive 1, and we'll do a positive 5 on this one here. Okay? All right, so let's take a look here. This would be negative 3 times negative 4, so that's going to be positive 12. This would be negative 3 times negative 2, so that's going to be positive 6. Negative 3 times 0, so negative 3 times 0 would be 0. This is negative 3 times 1, so we'd end up with a negative 3. And if we plugged in a 5, negative 3 times 5 would be negative 15. Okay, so we've got our points that work in the equation. Now let's go ahead and graph those. So the first one we're going to graph is negative 4, 12. So we're going to go back 4, and then we're going to go up 12. And then we immediately run into a problem. We have picked a point that produces a number that's not on our graph. Now this isn't too far off, so we can kind of come up with a ballpark. So negative 4 and negative 12, I would say that would be about right here. So I'm going to put a little dot right there, not too big. We're just going to estimate where that is for right now. And then let's make sure that everything lines up from here on out. So this is negative 2, 6 is the next one. Negative 2, 6, so we'd be right there. Put a big fat dot on that one. So if we're right about this, it should look about like that. So let's check and see how this goes. So 0, 0. Yeah, that doesn't look too bad. And then 1, negative 3. Looks good there. And then 5, negative 15. Okay, now we really run into a problem, because if we go to 5 and negative 15, gosh, negative 15, let me slide this down here. Negative 15 would have to be, gosh, way down here. Now, the thing that makes me feel okay about this is take a look here. If we put it about right there, over 5 and then down 15, gosh, that looks like everything lines up. Now if you get too far off the graph, maybe you don't put that. So I'm not quite sure that exactly how to estimate that, but these look pretty good. So I'm going to go ahead and connect these. So we're going to go, I wonder what's going on here. We're going to go ahead and connect these and draw a line from here to here, and then just make sure we extend it in both directions. So that looks pretty good. The point that we had up here that was off the graph a little bit lines up there. I'll just make this point a little bit fatter, And there we go. We want to make sure that we're as good as we possibly can be. And it looks like we were pretty well going to line up there with that 5, -15. Okay, so there's another one. Again, be really careful with these. So let's come down to this next one. So on this one, we've got a fraction in it. It says y equals -1/4 x plus 1. Now, when you have a fraction, you want to pick some numbers, and you want to do this really carefully. And you'll notice that I've done a couple of these, and I'm going to fill in this word in just a second. So let me show you how this works out, and it'll give us an idea of what numbers we're going to pick. Now, we definitely know that another number we're going to pick is going to be 0. So we already picked a few negatives. So watch what happens here if we do -1/4 times x plus 1. So this is going to be -1/4 times -8 and then plus 1. So you'll notice that if we've got a fraction in the problem, we might as well think of this as a fraction. So I can cross cancel the 4 with the 8. That's going to be a 2. So I've got a -1 times a -2. That's a +2, and then we'll add 1. So that's going to be a 3. Okay. If I do the next one, this would be -1/4 times 4 plus 1. Sorry, -4 plus 1. I'm going to cancel the 4's, so this is a negative times a negative, so that's going to be a +1, and then plus 1, so we're going to end up with a 2. Okay. Now you'll notice what happened here is I was able to cross cancel these every time. So you want to pick numbers that are easy to evaluate, and you'll notice that these have something in common. The denominator on this one, what I cross canceled with, was a 4. So if I pick numbers that are multiples of 4, I'm basically guaranteeing that I'm going to be able to cross cancel. So let's do this over here. Let's pick a 4 and let's pick an 8. We know those are going to cross cancel. So I'm going to expand this just a little bit so that we can see a little bit more what's going on here. And on this one, we're going to have -1/4 times 0 plus 1. So -1/4 times 0 is just going to be 0. So this is 0 plus 1. So that's going to be 1. And then we've got -1/4 times 4 plus 1. Again, 4 over 1. Those are going to cancel. This would just be a 1. So we've got a -1 times a +1. So this is going to be -1 plus 1. So that's going to be 0. And then the last one, -1/4 times 8 plus 1. This would be 8 over 1. Again, go ahead and think of that as a fraction. 4 goes in here once. 4 goes in there twice. So this is going to be -1 times 2. So that's -2 plus 1. So we end up with -1. Okay, so there are the points that we're going to use, and I'm going to switch back to my kind of fatter marker here. So let's go ahead and graph these. -8 and 3. So we're going to go back 8 on the x-axis. We're going to go up 3 on the y-axis. We're going to go to -4, 2. So that puts us right here. And again, once I get 2 of these points on here, I should know roughly where the line's going to end up. So I'm looking for something that's going to look about like this. So let's hope everything else lines up. 0, 1, so don't go right or left. We're going to go up 1. 4, 0, that means we're going to go 4 in the x direction and 0 in the y direction. So we're going to go over 4 and not go up or down. Okay, and then 8, -1. So we're going to go over 8 in the x direction, down 1 in the y direction, and there we go. So we'll notice that everything lines up here, and we're in really good shape. So I'm going to go ahead and draw the line, make sure that it goes through each one of those points. And looks good. Okay, so that's how we graph a linear equation using a table of values. I'm going to shrink this down just a little bit. We want to make sure that we're really careful as we're going through and doing the work, really careful as we're drawing the lines, make sure it goes through the points and looks nice. Make sure that we extend the line and put an arrow on each end. Extend that line to the edge of each one of the graphs. Okay, the assignment's very similar to this. Good luck with it.